Welcome to the Neoflex LightBend Reactive Architecture as a Foundation for Efficient IT Solutions webinar. So I am the head of data architecture for Rand Merchant Bank. I've been working there for 14 years, but I have been in the IT industry for the last 25 years. And in that time, what we've seen is an enormous move and unrelenting progression in data architectures that support business agility. And so what we're seeing over the last 10 years is a move towards a big data platform, a lot of work around predictive and prescriptive analytics, and companies or IT organizations trying to bring that data under management. And in the last 2 years in particular, we've seen the move away from predictive analytics, where companies have been trying to understand the requirements and the likes and dislikes of their customers and offer them a better experience, towards more of an inference-driven architecture, where the ability to assign behaviors to individuals within a data population has become the real focus of organizations. And so the digital transformation that we're seeing as we move into this inference-based machine learning world is really a means of survival. And although we've seen a lot of organizations around the world who have gotten into the inference business by way of their associations with third-party data vendors, we're seeing now that this COVID-19 has really brought about a very strong need to survive in a world where we don't really have the kind of markers that we used to have before. And so speed of big data processing has really become very, very important to organizations. We find that the ability to process large amounts of data in a prescriptive and predictive environment has certainly been a challenge for us. The ability to now consume ever-increasing third-party data vendors' data into an already busy pipeline is now requiring new world architectures that can support that kind of scale. Now, the new normal that we're seeing in the world around customer behavior is quite an interesting one. We are seeing that large organizations around the world, in particular in the finance industry, where sentiment and customer preference has been a big focus of the analytical world for them, have moved away from that, and they're largely moving towards this ability to understand the customer's behavior, and largely so that they can pick up new opportunities and try to understand where the market is moving and where the customers are moving. This new normal that has been driven by a sort of a post-COVID era for clients means that a lot more clients have moved their businesses online. Their interactions with organizations have moved online. And
okay, sorry. How can I go back?
And so I'll continue with that. And so we find that customer behavior has now become the de facto view for AI and ML in the post-COVID world, with inference of behavior being a critical aspect to that. Now, AI-powered IT solutions that help fight COVID in the finance industry in particular are really related to trying to understand the need of the customer in a world where data fidelity has diminished. And to that point, what organizations are doing is they're moving away from the public and social media type information towards procuring data from alternative data sources. In fact, alternativedata.org is a great resource for hooking up with companies that are involved in selling this kind of data to their customers, and this ability then to provide a better scale in an architecture to process more information with new questions and differing questions is a key factor for how we're progressing into the new normal with respect to AI and ML. So given that, I would like very much to take this opportunity to introduce David Ogren. David is the principal enterprise architect at LightBend. He has a proven ability to design and build and sell enterprise scale technologies. His background is quite diverse. He has experience in positions focused on application development, system architecture, technical management, and technology evangelism. Right, and so David is going to speak to us about the reactive architecture as a foundation. And David, welcome, and I'm handing over to you.
Thanks, Scott. While I wait for them to switch over my presentation, I am David Ogren. As Scott mentioned, I'm a principal architect at LightBend. And I have been an architect for over 20 years, a software architect and a programmer for even longer. And I tell you this not just to let you know that I'm old, even though that's certainly true, but because I've seen, I wanted to let you know I've seen a lot of kind of IT megatrends and how they've transformed our industry. You know, I was on the front lines for client server and that coming to the forefront. I was on the front lines as we went to Web 1.0 and Web 2.0. And I think one of the critical things about that has been that those things are not just technologies we buy. They are transformative. You couldn't just, I'm going to buy a relational database and now I'm client server. It required us to rebuild our applications, change the way we do things, and also just changed our business models. And it was the same thing with the web. The web wasn't just, I'm going to buy a web browser, now I'm done. It was a change in the way we built software and deployed software, and even the very business models by which we interacted with our customers. And, I go on this kind of long sidebar on my opening title slide just because we're going through that same kind of transformation right now. In fact, you can argue that we're going through several of those transformations at the same time right now. At the same time that we're going through a transition to the cloud, we're going through a transition with IoT, we're going through a transition with machine learning, kind of all at the same time. And kind of one of arguably the most important thing I'm going to talk about now, sorry, so for some reason these slides keep advancing. One of the reasons I talk about this now, arguably the most important piece of this, is that we have to change the way we build software and, in fact, change our very business models if we're going to be successful with these new transformations. And obviously, the word digital transformation means different things to different people, but I like to use it as a catch-all term for all of these kinds of mega trends and how they're affecting businesses. And the fact that software is so important now that as we do these IT transformations, it transforms not only IT, but kind of the core of our businesses. And the data backs this up. That's what this chart on the right is trying to show here, is that there is a rapidly growing IT spend around this as businesses, as Scott says, use these technologies for their survival. COVID has had kind of a diverse effect. It affects different people, different enterprises differently in how they do things, but in the aggregate, it is accelerating the pace rapidly. It has changed the way our businesses interact with people, since so much has to be digital now. people's behavior is changing so rapidly as they respond to changes in culture as well as just changes in law so rapidly that businesses have to change their business models rapidly. And they're, in some cases, rolling out entire business models in the matter of weeks. And that wasn't possible before. This is only really possible because of things like the cloud, because of things like managed services. And so people are having to, sorry, my slides are moving again. They're having to make these changes to their business models to adopt to this. I think, as I sort of alluded to there, the most whoever's changing my slides, please don't do that. The key element. Please. The key kind of mega. I believe you can hear me again. The key mega trend is cloud. The cloud is the enabler for all these other things. Even if you're, the key business functionality is machine learning, the reality is that the majority of your machine learning projects are going to be pushed out to the cloud. The majority of your streaming projects are going to be pushed out to the cloud these days. So cloud really is the bedrock of this digital transformation. And the key is, how are you going to be able to take advantage of that? We have a banking client in Europe that just took their existing system and lifted and shifted it onto AWS, and it increased their cost by 6 because they just took an application that wasn't designed for the cloud and threw it into the cloud, and it just wasn't optimized for that. And just like we had to change what we did with client server, just like we had to change what we did with the web, it's going to be the same thing for the cloud. And before I go any further, I really should define what I mean by the cloud, because I have a really broad definition of that. I don't really particularly care about whether it's public cloud or private cloud or hybrid cloud or multi-cloud or Fargate or K8 or K3 or really anything else. The key elements of what makes the cloud is that it is distributed. And this is a big change. We're moving away from monolithic architectures to environments where a distributed, virtualized environment is something that we take for granted. It is declarative, meaning that is part of my application definition. Is it's software-defined a deployment environment. And third, that it's elastic. That's as much a business model change as is a technology change. We now expect applications to go from 2 CPUs to 100 CPUs based off of demand, or 1,000 CPUs or tens of thousands of CPUs based off of demand, and not pay for resources that we aren't using. When I worked on trading systems in the kind of mid to late 90s, we would build systems with hardware that was 99% idle most of the time because we had to get past the opening of the trading day, and we just don't do that anymore. That's just not acceptable. We have to be able to scale up and down on demand. And in order to do that, we do have to build a new type of application architecture. The good thing is we've kind of already figured out these patterns. About 6.5 years ago, this paper was published called the Reactive Manifesto, and it highlights what things have to do in order to be successful in a quote-unquote modern environment. And by modern environment, it defines that it is going to be something that's distributed and elastic and declarative. And so really, what the Reactive Manifesto is talking about is what principles do you need to fulfill in order to build a cloud native application. We just didn't have that word 6.5 years ago. And the Reactive Manifesto is quite short. It's only a couple pages long. It is technical, but not overly technical. And so I have a link to it at the end. I really kind of encourage you to read it because it's such a quick read. But it underlines the 3 things that you need to do in a cloud native environment in order to be successful. The things that are new and important. And these things may sound obvious, but they do kind of have a specific technical meaning inside the context of the Reactive Manifesto. For example, the first principle that it says that you need to have is you have to be responsive. And that may sound obvious. It may sound like we've always wanted responsiveness. We always have needed performant applications. But in the context of a distributed environment, that has some specific definitions. Because if one user request generates dozens or hundreds of API requests behind the scenes, I can't consume a thread for every single one of those API requests. I can't do them sequentially. I can't make them as blocking calls. So part of what it means to be responsive, and that it details in the manifesto, is that they have to be asynchronous, that they have to be non-blocking, and they have to be lighter weight than threads. The same thing with resiliency. We have always wanted resiliency, but it has some specific meanings when you get into cloud native, because distributed architectures are going to have failures. In fact, Kubernetes, although even though, as I said, that's only one example, I mean, it's just going to kill pods. It's going to kill pods all the time as a way that it does things like upgrades and responding to failures and moving hardware around. So we as application architects have to consider that. That has to be baked into our infrastructure, this ability to handle and respond to failures and degrade gracefully. And then finally, elasticity, which I already really talked about, because it is sort of one of the key drivers towards moving towards this. It's now a requirement. I need to be able to survive peaks and load without having to have a bunch of idle hardware lying around. But the punchline of the Reactive Manifesto is that the Reactive Manifesto says that in order to meet these three criteria, you have to build your application architecture based off of asynchronous message passing. If you build your application architecture on asynchronous message passing, you are by definition asynchronous, so you get all this responsiveness. If you build your application on asynchronous message passing and there's a failure, you can just replay those messages and recover from that failure just by replaying your messages. Since you are relying on some backend to process your messages as the fundamental part of your architecture, you don't care whether there's 2 nodes processing those messages or 100. You don't care, in fact, where it gets processed. All you care is that your message gets responded to. So by fulfilling these principles of basing your architecture on asynchronous message passing, you get all of these kind of characteristics, or at least the capability to do so. Again, it's important to note this isn't just a technology that you buy. It's a architecture that you implement in order to be more cloud native. And it is a journey. It's not something that you're going to do overnight. It's something you're going to do to transform your applications, and you can do that. But again, the real point to make on this is the kind of traditional 2000s, 90s model of statelessness is not going to be successful in a cloud-based world. You need to adopt these reactive principles in a stateful approach to your services if you want to be able to scale, if you want to have this kind of resiliency. If you try to do a database lookup with every element in a real-time stream and you've got tens of thousands of elements coming in a second, that's just not a scalable model. Just a little bit about LightBend, the company I represent. We were the people behind the Reactive Manifesto. We kind of codified these principles, and we built a software stack that helps you build applications that fulfill these principles. And I'll go into that at the very end. We also are members of the Reactive Foundation. We run the Reactive Summit Conference. In general, are advocates for both reactive software and these reactive architecture principles. The other really thing I want you to take away from this slide is that we are just seeing explosive demand for reactive. As I said, reactive has been the key to being successful in the cloud-based world. So we're seeing basically 100% year-over-year growth for our kind of suite of reactive open source software. And these are all open source projects that we do maintain that help people build reactive projects. And again, I'll get to that a little bit at the end. Some of the people we've helped with this, one of the things we wanted to do is give some examples of how several companies, especially financial services companies, have kind of transformed their business with reactive technology. One of them is Brighthouse. Sorry, my slides are moving again. One of them is Brighthouse Financial. Brighthouse Financial is a spinoff of MetLife that handles annuity and insurance products. And as a result, they have to, for both regulatory and business reasons, maintain a lot of collateral to back up these assets. And their existing system to do this was written in C++, which you'd think would be highly optimized, but really took hours to process their current risk status. And that meant fundamentally that because their positions were changing so rapidly, that they couldn't get a real-time view into their collateral needs. And so they had to keep a buffer. They had to keep a lot of collateral extra. And we're talking about, trillions of dollars or hundreds of billions of dollars in collateral when we talk about this. So when we're talking about things like reinsurance and whatnot. So what they did is they rebuilt this with reactive software. They built this with Akka. They built this with Akka Streams. They built this with cloud-based infrastructure, in their case, OpenShift. So they now have significantly reduced the amount of collateral they have to hold on hand, on the order of tens of billions of dollars in collateral that they no longer need to carry on their books. And they also can make these adjustments in real time. So I jumped ahead. So that's sort of the end. The business result of that is that they really got to reduce their capital. Another example is PayPal. They had a Spring application that ran on hundreds of nodes that was doing some of the calculations associated with what they were doing in their transactions. And they rebuilt this with reactive technology, and that had a lot of benefits. So they rebuilt this in Akka and Akka Streams and Kafka and a library called Scubs that they were kind of building that based off these reactive technologies. And as a result, they actually had a kind of a bunch of nice results from this. First of all, they vastly reduced their hardware requirements. They took this from 200 virtual machines down to 8. So, over a order of magnitude improvement in compute costs. But it also reduced 80% of their code, since they didn't have to worry about all their failure scenarios, and the infrastructure was able to help them with all that code complexity. So they got a hardware benefit, but they also got a developer productivity benefit from moving away from a legacy Spring application into a reactive application. Which is actually in some ways a good way to Verizon, because they had something very similar. If you buy, elasticity was one of the key things I was talking about, is one of the things that ends up being a driver for this. And if you think about Verizon's mobile phone business, it has extreme elastic needs, because once a year, Apple's going to release on iPhone, and on that day, they're going to sell 100 times more phones than they ordinarily do. There are some other spikes, Christmas and a few other days of the year too, but it's a very elastic business where some days have huge spikes compared to others. In the Spring-based world, the only thing they could really do about that was to just strip out all of their monitoring, all of their kind of debugging pieces, just lock down the software, don't let any changes be made, throw every piece of hardware they had at it, and hope it stayed up. So what they did is they took all that, they took the Spring application, they rewrote it in Akka, they rewrote it in a framework called Play. It had kind of the same benefits. So first of all, it gave them this elasticity that they needed, so that they could stay up even on their busiest days and do it without having to worry about it, because it could kind of scale out and up as needed. Second of all, it prepared them for the cloud. This used to all run in-house, but by re-architecting this to be cloud native, it also helped them with their transition to AWS. It also had a big code reduction benefit, which, again, similar to what happened with PayPal, they were able to reduce a 40% reduction in their development costs. And it also helped protect their backend systems. This actually all had an Oracle backend, and making all those blocking calls to Oracle with some of the big challenges. So this let there be kind of a shield in front of Oracle so that they could remain responsive even when their backend systems were saturated. And actually, as a result, they had a massive increase of sales. This directly related into a revenue benefit for Verizon because they went from being one of the least reliable stores and losing customers to other platforms to one of the most reliable online stores for iPhone rollout days. I have two more quick ones I was going to talk about just to sort of illustrate a couple more important principles. One, I haven't talked too much about ML yet, so I wanted to give an example that incorporated ML. Capital One is one of the largest auto loan originators in the United States, outside of the car manufacturers themselves. But they kind of had a problem that when people would go to their website to apply for a loan, too many of the steps were manual, too many of the steps involved integration with backend systems. And so it took hours to do the processing and the underwriting of the loan, 55 hours on average. And by rebuilding the system in Akka and Spark and Cassandra and data pipelines, what they did is they took this existing process and they replaced that underwriting process with a series of ML models that are processed in parallel. So again, these principles of responsiveness, and that not only decreased their origination time down to under a second, but also let them essentially rebalance their risk on demand. It also really was transformative from a business model. They could now operate on a mobile phone inside a dealership and do these kinds of responses in real time. So it's kind of an important element of both how being able to keep your state in memory enables you to do some really transformative things with real-time processing, but also kind of the power of ML and how pushing ML into these data pipelines can let you transform some business models. All of those case studies are public, and if you want more detail on them, they're on our website. I'm going to put a link up in a slide or two here. But there's one more that I wanted to talk about that isn't a public reference, and I can't name the company by name because we haven't gone into production. But I wanted to talk about it briefly just because it matched so much with what Scott introduced this as, and also because it's what I'm working on right now. And it is a major international bank, and they want to get closer to their customers. They've got all this social data, and they've got all this transactional data. They've got all this data they're acquiring from third parties, and they want to be able to make the right decision in the moment to enhance those customer relationship, whether that be offers, whether that be interceding on some kind of account-based behalf, intervening on social platforms. They want to be able to make the right decision in the moment. And so what they do is they take all of these events, social events, transactional events, third-party event, and they feed it into a giant data pipeline where we qualify the events, we feed those events into a complex event processing system so that we can kind of correlate and analyze them. We take the results of that, we feed that into machine learning models, and then we feed that back into the business so that we can be calling business services in response to that. So again, another example of being able to use reactive technologies to really transform the business and make big changes to major enterprise systems. All these customers did this with a combination of both these architectural principles. One of the things we do as a company is we have a bunch of classes just on these architectural principles. They do it with the software that we both support and advocate around reactive technologies. I've mentioned several of them already: Akka Streams, data pipelines. And then they do it with our help around enablement. And that includes enablement both from our engineers, our support staff, our engineering staff, our product engineering staff, but also with our partners like Neoflex and helping people both enable themselves as well as build out these systems. Just as my one slide kind of promotion for those products. This is the products we sell. We essentially sell 2 products. We sell a product that you manage yourself that is a platform. We're an open source company, so what we do is we take all of those open source projects I listed in an earlier slide, and we combine them into a distribution. One kind of distribution focused on microservices and one focused on streaming data pipelines. If you want more information about those products, there's both I'm putting my contact information at the end, but obviously there's a lot of information on our website as well. And then we're also excited to start talking about a product we'll be introducing later this year called Akka Serverless, which is how do you take all these reactive technologies and offer them in a serverless kind of function as a service environment. So you get all the benefits of reactive technology without even having to worry about it, and just building your functions one by one. I'm just going to skip over this. We have a lot of great customers. There are a lot of great use cases on our website. And if you want more information, those case studies are available on our website. If you want more technical information, you want to start diving into those products, you want to start downloading the open source versions, you can go to developer.lightbend.com. If you want to look at some of those principles I talked about around responsiveness, resiliency, and elasticity, asynchronous message passing, and a little bit deeper about what that means and what the implications are, reactivemanifesto.org has the paper that was published around that, which has tens of thousands of signatories. And then always just feel free to reach out to me if you have questions about Reactive or about LightBend. With that, I'm going to wrap it up. I'm going to pass it back to Neoflex and Scott, where I believe we're going to introduce our poll questions.
Discussion from your side. What you guys will see now is that we're going to push some questions into the wouldn't mind just going through the questions quickly and answering them. That would be great. David, if I may ask you a question, please. I was wondering through the discussion, which industries do you believe will have the biggest potential for the new technology, for the new reactive technology, and given the accelerated move towards digitization, if you have a view on that, please.
As you again, I went through them really quickly, but if you saw in our one of my last slides there, our customer list, we do see transformation in a lot of industries. I've spent a lot of time working with supply chain. We've spent a lot of time working in hospitality, where they're obviously going through a tough time. But I think one of our top industries, and the one where we're seeing the most transformation, is of course financial services, which is, why we work with Neoflex, why we're so excited about talks like today, because there's just so much innovation going on in FinServ right now. I just frequently have FinServ IT execs just talk to me about how they don't even see themselves as banks or insurance companies anymore. They see themselves as IT companies that use that IT to offer financial services. So I certainly think financial services is kind of the key market right now.
The vast majority of the financial services companies are moving off their existing technologies and onto something that is a little bit more supportive of where they're trying to go. So we are expecting some questions to be put up, but in the meantime, I'm going to go ahead and introduce our next speaker. Dobbs is an expert with more than 30 years of experience in software development, in IT architecture design, and IT project management. I've had the fortune of working with him for about 10 of those years at the Rand Merchant Bank and here in South Africa. And Dobbs is going to speak to us about the practical insights from reactive solutions. And he's going to focus, again, particularly in the financial sector. Dobbs, if I could hand over to you, please.
For attending. I hope that you will find our presentation interesting and get some value from this. My presentation today will address some use cases for credit management and digital marketing in the financial industry, as Scott mentioned. Even though we are talking about specific implementations, we can identify some architecture patterns that can bring business value in many other business domains in the financial sector and other business areas, including but not limited to telecommunications, to insurance industry, and so on. Real-time offer metrics calculation is the first project that I want to present to you. And okay, I'm just trying to get there. Yes. And I will start with that project that addresses a real-time engine for next best offer models. And the client is one of the biggest Russian banks with over 375 billion US dollars in asset under management. And this is close to the border of world's top 100 largest bank ranking. As you would expect, one of the main services at the bank is obviously credit. The bank is using customer profile, which is a complex abstract formed by customer master data, transactional data, and set of complex business rules to build a real-time engine for cross-selling models. And the architecture of the legacy solution was mostly monolithic with a few main components. And unfortunately, I have to mention that most of my life, I also was working on monolithic systems. They have some values, they bring some value to the business, but obviously there are some limitations that we are facing, and that's the reason that we are coming with the reactive architecture, with the real-time streaming applications and things like that. And the architecture of that legacy solution was built on the, I will simplify that very, very much by saying the customer would connect or request to the bank data warehouse as a primary source of data. Will request that on UI. There is an enterprise bus, and that is a set of services that are SOA-oriented, and data warehouse as a prime data source. And I will mention only some of the main constraints of that solution. At peak time, there are about 500 customers' requests that they want to get answered, and there are about 500,000 customer requests per second. The current platform couldn't handle that, and they could handle only about 10 times less load. The platform is not scalable to the required level, or is not scalable the way that it's economical to the bank, because even if you scale monolithic system, you cannot use infrastructure properly. You cannot scale up and down when required, or it's very difficult to do that. And the platform is deployed as a single unit. There is a single shared database. The system communicates with the synchronous method calls. There is a long deployment cycle time, and that is something also, what is very important and is a big constraint. Sometimes deployment time could go from days and weeks to months. And there is a long deployment life cycle. As I said, data is not consumed at the time it is ingested. Usually, when we have a data warehousing system, the load happens once a day, or maybe we can schedule job to run a few times a day, but it's very limited because we are talking about big volume of data. We are talking about batch processes, and obviously we are talking about data that are not up to now. Data are usually 1 day old, and that is also a limitation when we come to decision making or supporting decision making process. And the client's management recognized that the platform is outdated and cannot support this mission critical process. They have asked Neoflex to come up with a solution, and what they have done, they have launched a pilot project for this. And the key pilot project deliveries defined by the customers were prove the technology stack and architecture for the real-time cross-selling platform of the bank's products, include online data sources, including CDC and trigger events, to the cross-selling decision flow, establish a flexible deployment environment for data flows, and cross-sell decision strategies based on microservices architecture. Obviously, reactive architecture in the back of that, and reactive architecture approach, which support and define some principles for designing real-time distributed systems. And Neoflex came up with a redesigned system that is based on reactive patterns, including some components from LightBend, our partner, and great components from them. And that was based on Lambda architecture. I have to point Lambda architecture as a key because, in many other areas and domains, we can use Lambda architecture. For instance, when we want to build a modern data warehouse, we can expand our already built data warehouse by introducing big data, fast data, and introducing real-time component, which can make all investment that we have done already to pay off, but also brings us to the next level, that we can introduce big data and make process much faster and much more responsive. On the slide, I will just go and pass to that. You can see the high-level architecture that Neoflex proposed to the bank. The main components, and I will start with something that is customer profile data mart, intentionally, because that is a quick read, write data access by key build for customer reporting services, because customer really wants to get as quick as possible a response to the request or requirements, or the requirements which that they were proposing using UI. ETL batch process to load the daily customer profile into customer profile data mart, and that is a part that you can see here, and that process is practically data warehouse is loaded daily, usually daily, and they are getting pre-built customer profiles based on information which they have. What really is very important, that is a part that is talking about streaming of data, and that is real-time continuous customer profile updates and real-time continuous offer metrics calculation, the other part of the system, which is also very, very important. I will talk about those components in some more details. Core systems are bank systems that store user data, first client data like client account, client deposits, and other data that forms client profile. There are also systems that store customer relationship management data. This is the part here. And any changes made on the core systems and CRM data are captured using Oracle CDC and Golden Gate tools that can publish, can pick up event, or changes on database, connecting to database log means very low stress on the underlying system, and they publish them as unbound streams of data to Kafka. Apache Kafka is distributed message bus, and also data will be published in ODS or operational data store, respectively, for later use. Continuous customer profile update is another block in the architecture or architecture block, and customer raw data are unbounded stream of events, which reflects the changes on customer-related data in the core systems and CRM, as I said. And Kafka works on abstraction called topics, and each topic is a part of a message queue, forms a kind of data stream. And we calculate new customer profile based on each Kafka topic and interpret them as a stream. As the main goal of this block is to capture changes that are happening on customer or bank systems, and to go and update information and update customer profile DB. We are also publishing the updated customer profile data to Kafka messages bus for further use by decision server, another big component and block of the solution. And the main goal of this block, of that block that I was talking about, the first one, is really to, in near real time, to update a customer profile and store data in a NoSQL database. In our case, we are using Couchbase, but this could be any NoSQL database such as Cassandra, MongoDB, etc., on premises or on the cloud. And the reason why we are storing data, and I'm talking about customer profile, why we are storing data in NoSQL database is that NoSQL database doesn't really require join operations, because when we talk about the customer profile, as I mentioned before, there are about 3,000 records per customer stored in the customer profile. And we want to avoid the join operation, which can slow tremendously process or response time. And using NoSQL database, we are eliminating joins, and we are speeding up and getting response from the practically from the customer profile much faster. This is the first data flow that enables us to extract bank system changes based on event sourcing approach. And after that, we publish them as unbounded stream to Kafka message bus, structure them as a topics, and that is what I'm talking about, this part here. And we read them as a raw data, calculate the new customer profile, store updated customer profile data in NoSQL data, and publish new customer profile as asynchronous messages to Kafka message bus. There is a very important point related to reporting domain built on the top of NoSQL database. And the client and his interaction with the system UI is still the same. We don't change that. But we have built data mart service to interact with NoSQL database and process the customer requests, because we want to speed up that process and as well make the response time to the customer very, very quick. And the layer is built using reactive programming based on Java Reactor and reactive streams in Java. The request is sent as an asynchronous message, and as well, the response from the system is sent back as an asynchronous message. Obviously, reason for that is that we are not making waits on the queue, because we are sending asynchronous message and follow practically all the reactive architecture principles. And just very important thing that people are very often mixing reactive architecture with reactive programming. It's two different things. You can have a reactive programming in place, but if that doesn't comply with reactive architecture principles, that system is not really compliant to our reactive architecture principles. And that is, for instance, when you develop, for instance, some modules and you implement on a single node. Obviously, that the single node is not, the system is not resilient, and that doesn't comply to reactive architecture in general. The client and his interaction with the system that way, is much more speed up. And we are, the second part, maybe I should talk about the second part of the story, is that the project was to go to real-time marketing. And the customer profile is a source for other bank services. And these bank services bring a lot of value to the business. In our case, we are talking about bringing value by introducing decision matrix, and which will now have a closer look, And sorry, I have to go back to the previous slide. And the bank is interested to create an offer to customers based on the customer profile. And there are a few domains used to load data into the offer matrix. The offer matrix is preloaded list of bank products that are calculated and preloaded for customer. And it is based on the customer profile, data mart, decision server, all components that I'm talking about. And I would like to, go and skip that part because you can see them on the slide. that I am not getting over the time. But what really is very important that there is a portion that I want to point, and that is decision server. And decision server is a process that is built based on some business rules introduced by business users, and using a business rules engine called Rules, which is open source business rules engine. They create some business rules, and based on some changes on the customer, we go and populate offer metrics. Practically changes that are happening on profile, and based on business rules that we put in decision server, we can go and create offer metrics, which, for instance, if you deposit a lot of money on your account and you're keeping that for a while, a bank can go and offer you some new credit facilities, or any change that is happening, on your customer profile. Again, in milliseconds, will be updating offer metrics, and business can go and, based on some marketing policies, they can go and offer you new products, or some other offers could be done, for instance, automatically. And all of us, we are getting our SMSs or emails, saying the bank will offer you some more services based on the changes. And now, because of the tremendous speed that platform can support, you can get that almost immediately as changes are happening on the customer profile. Technology stack that is here is really Oracle Golden Gate, the Oracle CDC, which are very well-known technologies. Oracle Golden Gate is recommended by Oracle for replication. Kafka, Red Hat OpenShift is used for Microsoft orchestration and run. Spark allows us to operate on data in a streaming manner. We are using Spark libraries to treat streams as microbatches. LightBend Akka, that is very important. We use LightBend Akka to calculate, to practically, that is one of the LightBend leading products. It is reactive platform for microservices. And you can see here, and we can use that to recalculate offer metrics, and using also Akka implemented with the actor model, which is a foundation for reactive tools like Lagon and Akka Stream. Also, Akka, with the Akka model, models, when actor models is very good for calculation. And the speeds up calculation makes all that process simple, because we are getting raw data, as you could see. We are using Akka practically to do a split and calculation, and do that in parallel, and do that very fast, to be able to populate offer matrix on a relatively fast way. And we are calculating that in almost real time. And the key business values that we are demonstrating here are the next slide. Really, possibility to be faster than competitors. This is hypothetical, obviously, but really platform can now perform more than 500,000 requests per second, and can be scaled up and scaled down, which is making the whole process very, very efficient. There is a flexibility. Each decision strategy is implemented as separate microservice and can be deployed separately. And that is really going to make the whole environment much more flexible, because now deployment, if you want to change one of the microservices, and for instance, if you go to previous slide, decision server could be created as a microservice, and that's a good example, because if you create that as a microservice, we can go and easily change the rules and only deploy that microservice on production, and that will take a few hours instead of when we go to monolithic applications, can take days and maybe even months to get deployment done. And testing can be done only of that microservice. We can introduce in that process as well DevOps, which practically enables the process to be very effective, change the decision server the way how we want and quickly as possible. And if you see any anomalies, we can react immediately. And that should be all about, and the high performance, obviously, because key solution components are native to mass parallel computation based on reactive architecture principles. We introduced Gamma architecture, which can be pattern for many other projects, as I say, and that was a very, very successful pilot project that Neoflex has, and practically give them opportunities to use similar pattern and architecture pattern in many other projects and bring value to other customers as well. The next project that we have done is a new real-time analytical platform for the leading credit bureau. And that is, again, I will give you some project background. Client is a leading Russian credit bureau, a subsidiary of the #1 Russian bank. And the business case, the credit bureau really had a platform that was working on the market for many years, almost 20 years. The platform was outdated and they couldn't expand their business. They couldn't scale the platform as well to the level required by the business. And as you know, the customer for credit bureaus are big banks around. It's really there are a lot of data that they have to process and a lot of requirements from the credit bureau. And they also decided to come to Neoflex and to define some key project deliveries and try to introduce LightBend to help them. And the key project drivers to implement a new platform supporting real-time trigger-based value-added products to enable more online data sources for the value-added products development. Online data sources can include social media extracts, which practically brings big data into the environment, which is very, very important because, for instance, like a Twitter post can be processed as an event and can trigger some actions and update some information on the credit bureau that can be passed to the banks. For instance, if there is a fraud detection or someone is putting some unusual post or some customers of the banks are putting unusual post on the Twitter. Implement infrastructure for rapid development and production of ML AI components of the value-added products. And that practically, when we come to the next slide, we will see what are really key solution components or build architecture blocks that are used to build the solution. And I will talk about them a little bit in more details. And we can see that there is a stream processing of data. We process credit history data that are sent from bureau clients and banks to the bureau. And we are also processing requirements from the customers that are bank clients, or the bureau clients, which are banks, and they are requiring some information. And for that, they are using API gateway. It's open API environment when they can pass information in and they are getting information out. And that is one business to business gateway. We are using also a structure that is called Lakehouse Analytical Sandbox and ML Ops. And really, Lakehouse is an evaluation of data lake implemented with low-cost storage used for data lakes that is bringing similar data structure and data management features to those in data warehouse. But what really is advantage that we are using the same low-cost storage and that we don't have a classical ETL jobs to populate the data. And responsiveness from this environment is tremendous. And that can be used later for analytical sandbox and for further use from the other applications as well. Analytical sandbox in development environment for data scientists and can be created as a separate domain, and that can have also their own Hadoop data store, because we can extract data, and that could be done in ETL process, extract data from a data lake and from Lakehouse, as required by data scientists to go and deploy their models. And online triggers are really very important as well, because credit history changes are split to streams, and that is crucially important. When we go now to bigger slide, we can see that data are coming into API gateway as data files. It's a kind of batch approach. Also, requests for information are coming as a data files. Means all communication through API gateway, in this case, are happening by data files, and that files could be massive, could be even gigabytes, because banks can send a lot of changes on the credit history. And what really is amazing here, that they are stored on the S3 object storage, but at the same time, data are from data files are splitted to unbound on stream of messages, and that is crucially important. That enables practically streaming processes from there. We really don't have any batch architecture in process, but from data that are getting from data files and split into streaming data, everything else is real-time processing using the similar patterns that we have in the previous architecture. And this process enables extremely fast processing of data and loading of the results in the responsive layer for reporting to the clients. Scoring is a process for calculating customer stabilities, and also is based on events that are coming from credit history, and from this sandbox that is done by ML models, and together that is practically a scoring process that calculates customer financial stability and can send information back to the customers. Benchmarks, sometimes the banks or bureau of customers, are requiring some information to rank the clients or banks, to rank the customers, and to send information back using an analytical platform. Anti-fraud, very, very important part, and is built practically to prevent fraud events. And domain is based again on machine learning models and credit history changes, but also could include, big data load and include that process as well in the whole scope. And really, when we talk about conceptually about the data flow and the architecture blocks, you can see that API, and I will just rephrase that, API gateway is built for interaction with bureau clients, with banks. Incoming data are file-based. There are two main architecture layers. The first is a layer that is referring to personal data management, and storage layer in product and sending data, storage layer, which is Hadoop, and stores data in data lake and send to Lakehouse, to the second layer, which is a product factory layer. Very important thing is that when we send data from personal data management and storage layer, that we are depersonalizing data. Practically all personal information, only keys to MDM, which is part of the solution master data management component, are a strip of the messages. And that definitely, reduces the volume of data and size of the data and speeds up the process as well. And all the updates and requests to the analytical platform are loaded into product factory layer, which has also from Lakehouse, we are going to analytical database that is built on as a green plum. It's an open source solution, and and that has the first one, the cost-based optimizer, which speeds up inquiry to analytical database for analytical processing tremendously fast. We are using Event Bus as well, and analytical sandbox, as I said, is a separate, domain, and could be built as a set of services, microservices as well. And data that we are using here are could be built on the data store that is specifically built for analytical sandbox, and could be sourced from Lighthouse, from analytical database, from data lake, from anywhere where data scientists require information to build and successfully deploy their models. And for deployment, after they are testing and training data sets, their models, they can pass information to production environment using MLflow. And practically, as a difference from the previous presentation, when we have server, the decision server that was doing that was holding all rules and practically create all sophisticated approach to data. Here we are using, and that is a big difference between those two. We are using ML and AI, which practically is more efficient and is much more modern approach, because doesn't really need human intervention, because all these models, they can train themselves and they can make conclusions, and bring some business value, and from there go to real time, and all data, which are going into the data science, together with data science models implemented on them, they go to real-time database and to client data marts. And client data marts, again, are constructed on the NoSQL database, again, with the same reason. And that the query practically that is running on the top of them is very much is much faster than using a relational database. As you can see on the customer platform, we have few blocks, and one is a credit history that is outcome from this. Triggers, we talk about them, and scoring as well. Scoring and triggers are done using Spark, because, as I said, Spark is very fast streaming framework. And in the process, there is like I'm just trying to find. Okay, I will go to main technologies. Probably that would be easier if I go just and specify that on its own. But the whole system now, it's very responsive, is elastic, is resilient, and is message driven from the time when data get into API gateway as a data files. From there, we don't have practically batch processing. Everything is done by data streaming. And just quick overview, because I know that I'm running over time. Kafka is one of the components. We talk about Kafka, S3 object storage, Red Hat OpenShift built on the Kubernetes, Apache Spark Stream, Cloudflow is a LightBend framework that dramatically simplifies development, deployment, and the management of multi-purpose streaming data pipelines in Kubernetes. And you can see that one here that we used practically to stream data and to put them in the proper messages that we can process them successfully later. And data lake is built on Hadoop. Lakehouse is also built on the Hadoop, and usually they are on the same premises. analytical database, Green Plum, is a big data technology based on NPP architecture and Postgres open source database technology, and that is the first cost-based optimizer that can deal with a massive volume of data. We are talking about terabytes of data, and the analytical sandbox is done on also on platform called Jupyter. Model Repo and ML Flow is an open source platform to manage the ML lifecycle. We can very successfully and easily deploy new models that we are building, because we can create them the way that we can easily and successfully replace model that is outdated or is not really giving us answers that we want. Real-time database is Cassandra in our case, but could be any other SQL database. Clients data mart are Postgres. Credit history and trigger are done in Flink. And scoring stream ETL is done in Spark. And Spark practically is used when we move data from data lake to lakehouse. And also when we move data from data lakes to analytical sandbox. And key values that we are facing here are, we reduce time to market for the new value-added products. We are introducing a new generation of real-time products, easier deployment and onboarding of ML-powered products with ML ops infrastructure. There is a high performance and scalability. Response time is less than a second, and that is really phenomenal. Instant delivery of value-added products through the digital channels, open API layer, when we talk about that API gateway. We simplify piloting and testing of products by new and potential clients, because obviously we are implementing a microservices architecture all around. We are simplifying, we are bringing ability to use new online data, especially data from social medias, images, biometries, big data practically in the environment. And we are using them as well to trigger some events and in changes that could be done in customer profiles. And we are also, bringing value that practically we are compliant to regulatory compliance. And the data are high quality data, because we can introduce in the process, and we are introducing in process data quality check. We are introducing MDM solution, which brings value to the environment tremendously, because we are stripping out all personal data that are coming from banks, and sometimes that could be really incorrect, because some of them are captured even on the way that is not the structure on the most appropriate way. And somebody of experience in financial sectors, we are bringing real-time decision management, including loan originating. We are introducing AI-powered collection scoring. We are doing real-time offerings, as we mentioned now. When we go and do offering based on metrics, offer metrics. Anti-fraud, obviously, which is now expanded not only to the customer data. We are bringing big data in the process as well, and using ML and artificial intelligence in the process as well. Anomaly detection in IT security events. We are bringing a lot of securities, and we can also introduce ML and AI capabilities. Business and IT operations automation, smart routing of incoming inquiries, AI-based service desk, and things like that. Benefits, obviously, it's systems that we are building using these architecture patterns. I'm talking about the whole, both of these use cases and many other projects that we went through. Systems are responsive. It's low latency and high performance. The system is resilient, or our platforms are resilient, graceful, non-catastrophic recovery. Very important part is that, as David mentioned before, business has to be involved in design and find out what really kind of catastrophic events are on the system, and based on that we can go and minimize really the process of a system not really be responsive. Systems are elastic because they can scale up and scale down, which is tremendously important because especially in this COVID time, that when you can save on infrastructure or use your infrastructure on the most effective way, that really is a big contribution from companies like LightBend and Neoflex, that can reduce the running cost of the products. Normally, there are challenges that are made. There is adoption of cloud infrastructure. Usually, companies, and especially in South Africa, companies are very resistant to cloud environment, which really, I think, should be addressed. The complexity, application architecture, and bringing real-time distributed systems in place, and bringing architecture principles and architecture in general so reactive architecture is really something that requires high-level specialities. And from that point of view, I think LightBend and and Neoflex as well, based on experience that we have and success rate that we have in building systems like this, can help tremendously. And practically, we partner with the clients. We are not leaving clients after we develop that. We are training them. LightBend has a great academy for that. Also, they launch, and I'm not sure if David mentioned that, architecture launch, the product which practically enables a client who is implementing first time this kind of platforms, that they can bring the best architects, and they can work on the projects to be successfully deployed. And also they train in meantime, they train the customer staff. Also Neoflex, is always offering continuous support. It's not a once-off approach. And there is also some organizational change that has to happen, and the organization has to adopt to the new way of thinking and new way of working, and that includes monitoring, management of infrastructure and applications, involvement of business, especially in domain-driven design. Business is so important, to bring to come with their knowledge and to define properly domains that we can, on most effective way, identify microservices and deploy the platform or reactive architecture in the environment. And I think that should be all from my side. I will hand over to Scott.
Thank you very much. That's fantastic. What a wonderful presentation. So it should be pretty clear to everybody at this point that world-class technologies, world-class platforms that enable data elasticity and comprehensive mechanisms to process large amounts of data are actually within your reach. You have some of the best people here in the world that are talking to you this afternoon, and you should try to make use of that as soon as possible. However, it should be pretty clear to everybody that the ability to manage and establish a world-class big data platform is within your grasp, and you should then just use the opportunity to reach out to LightBend and Neoflex and get some input into your architectures, and let's see how we can evolve you to a world-class architecture. Thank you very much for joining us this afternoon. Scott Spencer saying goodbye. Have a great afternoon. Thank you very much, guys.